Welcome to the DIY Honda Garage channel. The diagnostic trouble codes, DTCs B1130 and B1131, indicate specific malfunctions in the power window system of the Honda Odyssey model years 2011 to 2017. DTC B1130 pertains to the front passenger's power window motor A, while B1131 refers to the power window motor D. These codes are indicative of pulse malfunctions that may lead to improper operation of the power window system. The motors responsible for moving the front passenger's window are an integral component of the vehicle's power window assembly, which consists of switches, wiring, and motors that function together to allow the window to operate smoothly. The location of the front passenger's power window switch is on the door panel, while the motor is usually situated within the door structure itself, connected by wiring harnesses. Proper diagnosis and repair involve understanding the interconnectivity of these components and how they contribute to the overall functionality of the window operation system. DTC B1130 and B1131 signify a malfunction in the power window system concerning the front passenger's power window. The affected components include the power window motor and the window switch, which are essential for the operation of the window. The power window switch, located on the door panel, initiates the command to either raise or lower the window when pressed by the user. The power window motor, located within the door assembly, translates this command into motion, controlling the movement of the window itself. These components are interconnected through wiring harnesses, which relay signals and power. These error codes point out that, for some reason, the high pulse signals, which indicate the window motor should operate, are not being properly processed or generated, leading to a failure in window operation. When troubleshooting DTC B1130 and B1131, several possible causes need to be considered. First, a faulty power window motor may be the root of the issue. This could be due to internal mechanical failure or electrical shorting, which can prevent the motor from receiving proper signals. Next, damaged wiring or connectors can interrupt the flow of power and signals between the motor and switch, leading to malfunctions. Insulation breaks or corrosion at connection points can exacerbate this problem. Finally, a faulty power window switch must also be examined. If the switch itself is malfunctioning, it may not send the correct signals to the motor, resulting in the error codes being triggered. Diagnosing these components systematically is crucial to pinpoint the failure accurately. The symptoms associated with DTC B1130 and B1131 manifest prominently in the operation of the front passenger's power window. The most noticeable symptom is that the power window becomes inoperative, failing to move up or down when commanded. This can be frustrating for users, especially if the window remains stuck open or closed. Additionally, the presence of the error codes indicates that a malfunction exists within the system that requires attention. Furthermore, the user may notice that pressing the power window switch elicits no response from the window motor, which reinforces the idea that a breakdown in the system's functionality has occurred. Each of these symptoms draws attention to the fact that further diagnostic steps need to be taken to restore proper window functionality. The first step in troubleshooting DTC B1130 and B1131 is to clear the diagnostic trouble codes using the Honda Diagnostic System, HDS. The HDS is a specialized tool that interacts with the vehicle's onboard computer systems and allows a technician to reset any existing DTCs. This step is crucial because it establishes a fresh starting point for the diagnosis and confirms whether the problems are persistent or transient. After clearing the DTCs, it is important to note that this procedure should be performed before conducting any further diagnostic actions. Doing so helps to eliminate previously logged errors that may not be relevant to the current condition of the power window system. Remembering to use HDS is essential for achieving accurate results. After clearing the DTCs with HDS, the next troubleshooting step is to turn the ignition switch to the lock position and then back to the on position. This process resets the vehicle's electronic systems, allowing them to reinitialize and align properly with the control units. By ensuring the ignition switch is set correctly, the technician can observe if any issues reappear immediately after restarting the system. It also has a primary role in re-establishing communication between various electronic components involved in the power window operation. This is important to verify that the system recognizes the reset action and scan for any faults that may have been masked previously by intermittent failures. The third step involves manually opening and closing the front passenger's power window using the window switch. This action tests whether the power window system responds properly after the ignition reset. By performing this manual operation, the technician can evaluate the window's mechanical functionality and the effectiveness of the electrical components involved. If the window operates smoothly during this test, it points towards the potential for an intermittent failure that may require further investigation into wiring or connectors. Conversely, if the window remains unresponsive, it indicates a more systemic issue. This manual check serves as a practical approach to diagnosing the functionality of the power window assembly. After testing the power window operation, the next step is to check for DTCs again using the Honda Diagnostic system. This crucial action allows the technician to identify whether the same DTCs B1130 and B1131 are still indicated in the system. If these codes reappear, it alerts the technician that the previously diagnosed issue remains unresolved and demands deeper intervention. Conversely, if no DTCs are present, it may suggest that the issue was indeed intermittent, or perhaps a temporary failure. In this case, it is essential to conduct a thorough check for loose or poor connections between the front passenger's power window switch and the power window motor to ensure a reliable connection for future operation. In this step, the ignition switch must be turned to the lock position to ensure the vehicle's electrical systems are offline. This is a safety measure before proceeding to disconnect electrical connectors, minimizing the risk of short circuits or electrical shock. It's crucial to perform disconnections when the system is powered down, as it protects both the technician and the vehicle's electronics. Additionally, ensuring that the vehicle is in a form of standby mode can avoid further complications. Once this precautionary measure is taken, the technician can proceed with disconnecting the necessary connectors from the front passenger's power window switch and motor for a detailed inspection. The next step is to disconnect the front passenger's power window switch connector, identified as the 37P connector. This action requires care to ensure that the connections are cleanly severed without damaging the terminals. With the connector disconnected, the technician must check for continuity between the switch's terminals and those of the power window motor, which is connected by the 6P connector. This step ensures that there is a reliable path for electrical signals to flow between the two components. An absence of continuity may indicate that there is a fault in the wiring or the connector itself, while confirmed continuity suggests that both the switch and motor may function correctly. A continuity test is vital in the troubleshooting process to systematically eliminate components that may be causing the malfunction. Following the disconnection of the power window switch connector, The technician should then proceed to disconnect the power window motor connector, referred to as the 6P connector. Similar to the previous step, this action must be executed with caution to avoid damaging the terminals. Once both connectors are separated, conducting a continuity check between the front passenger's power window switch 37P connector and the power window motor 6P connector terminals is the next logical step. This test helps to verify whether the electrical connections between the switch and motor are intact. Any breaks in the circuit would indicate potential issues within the system, prompting a need for repair or replacement of any faulty wiring or connectors identified during the continuity testing. The results from this continuity check can significantly impact the decision-making process regarding the necessary repairs. After completing the previous troubleshooting steps and making any necessary repairs, verifying the functionality of the power window system is paramount. This involves restoring the connections to both the power window switch and the motor, ensuring that they are securely fastened to prevent any future disruptions. Once the connections are re-established, the technician should test the power window to confirm that it operates as intended. A successful test, where the window functions smoothly in both directions, affirms that the troubleshooting and repairs have resolved the issue. If the window remains unresponsive, it may necessitate further diagnostic action to explore other underlying causes. Verification is an essential closing step in the repair procedure to ensure that customers receive a fully functional vehicle. To prevent issues similar to DTC B1130 and B1131 from recurring, implementing routine preventive maintenance is highly recommended. Regular inspections of the power window switches can catch early signs of wear or malfunction, ensuring they remain in optimal working condition. Additionally, the integrity of the wiring should be checked periodically to avoid potential shorts or disconnections that can lead to power window failures. Keeping the door assembly clean and free from debris also contributes to smoother operation, while lubricating mechanical components can enhance their lifespan. Educating the vehicle's users about the importance of gentle operation can further minimize stress on the system. By following these preventive steps, long-term performance and reliability of the power window system can be ensured. In conclusion, diagnosing DTC B1130 and B1131 is vital to restoring the functionality of the Honda Odyssey's power window system. Identification of the specific components involved, from the window switch to the motor, allows for targeted troubleshooting steps. Systematic testing and verification uphold the integrity of the repair process, ensuring that the window operates as expected. Additionally, regular maintenance serves as a preventive measure, extending the lifespan of these components and mitigating future issues. Understanding the symptoms and causes associated with these DTCs enables technicians to offer effective solutions to enhance vehicle reliability. By maintaining regular checkups and responsive repair actions, a consistent and trouble-free operation of the power window system can be achieved. Please like and subscribe to the channel. See you next time.